Perfect. They're counting. That means there's no units. You get out of the beach someday, and there's 10 waves come in per minute. You get out of the beach the next day, and there's 12 waves coming in per minute. You say, oh, the frequency increased. I'm counting a higher number. So this is waves per time, which you can write for frequency, and you're counting waves per time. Now we're going to change seconds to minutes, so we don't have to use decimals. Anybody know what's normal for the open ocean? Put in your notes, 7 waves per minute. 7 waves per minute. That means you gotta go up and down 7 times in a minute. What happens to some people? They get seasick, because your stomach doesn't like that. They get seasick, and they're leaning over the railing getting sick. All right. Letter, what are we on? 3? Period. Letter E is period. What did they do to get period? Realize these A's and B's from this diagram. You get a different diagram, you gotta watch your E's and B's. You labeled it. Alright, look. Number per time, time per so wave per time, time per wave. So what they do here? Reverse. Took the inverse. Period is inverse of frequency, which means if you know one, you know the other, because you just flip it. So period is you're actually timing how long it takes the wave to go by. Crest to trough to the next crest, you checked it off, well, how much time passed? Anybody know what's normal? Then you note 8 seconds. 8 seconds. This is actually the main measurement for waves to see what's going on and how much energy is present. We all like to know what the wave height is. How rough is the water if I'm going out there? And this is going to tell us more about what's going on in the ocean, as we'll see in a minute. Letter F. What is it we think waves are doing? You stand at the beach, what's the wave doing? It's coming toward us. We think it's moving. How do you measure motion in your car? Check your speed. Okay, we got there. Speed. Letter F. Somebody give me a sample speed for your car.
55.
55 what?
Miles per hour.
Miles per hour. What do miles measure? Miles measures distance. Which one of these definitions is distance? Wavelength, so put that down here, wavelength. Miles per hour, what do hours measure? Time, which one's time? Period. Period, so divide by period. Wavelength, divide by period. It's going to be speed in wave terms. Wavelength on top of period. Anybody know how fast ocean waves are moving? In your notes, 30 miles per hour. Surfers are having fun. 30 miles, they're moving along, riding a wave. When the surfers out there riding a wave, what are they doing the whole time they're out there? They're falling. It's a controlled sustained fall off of one wave where they hop on to they hop off, and they're doing 30 miles per hour. And it's water. They're having fun. So what we're going to do is check out the state of the Atlantic Ocean right here, right now, today, by hooking up to an offshore buoy. There are 3 buoys offshore of Brevard County. The one that was 4 miles out was set up by Scripps Institute from San Diego. We're doing some research out there. We got another buoy 20 miles out, then one out on the map here 120 miles out. We're gonna hook up to the closer one, the one that's 20 miles out. This is a picture of what it looks like. Kind of hard of perspective here, because all you got some waves, and how big the waves are. How tall you think that is?
4 or 5 feet.
15 feet. It's a federal violation to moor your vessel to one of these offshore buoys. The Coast Guard catches you out there, you're in big trouble. They're moored down to the bottom of the ocean. Some of our hurricanes that go by cause such big waves to occur, the buoys break their mooring. Matthew from 2016, the one 120 miles out, broke its mooring. How big was the wave? 53 feet. You think we don't get big waves here? You get offshore enough, you got some monsters. They found the buoy off of Jacksonville, sent it in for repair, now it's back out there. So what we're gonna do is check out with some equations. Yes, we're gonna do a little bit of math here. And see just what the state of the Atlantic Ocean is out there today. Here's what you can do for letter G. Copy that down. Buoy 20 miles off of Cape Canaveral. Today's October 7th. You have 5 readings. And then we're going to solve for 3 more. Air temperature 80. It's still summer. We should be getting to fall here, but it's still summer for us. Water temperature 83. Wind east at 22. Blowing pretty good out there. Wave height 7 feet, period 7 seconds. We'll solve for speed, wavelength, and frequency per minute. We'll take a look at what the state of the Atlantic is out there this morning. Who can tell me from last week's class why these two should be about the same? Give me a word. Air and water temperature should be about the same. Air is touching water, so some heat may be transferred, called conduction. All right, let's see what we get here. First, we're not going to solve for speed. The textbook puts down speed as small letter C. Here. Speed in metric system, meters per second, GT divided by 2 pi. We're not going to look at how this was derived, but that's what they got. What's G? What's G? Holding you down. Gravity. When the wind pushes the water up to a wave, the water doesn't want to do that. It wants to be back down again. You try to make a pile of mountain of water in your sink, it doesn't do it very well. Gravity is a restoring force. What's T? Time. Which one's time? Period. Okay. Divided by 2, that's the constant. Pi. When do you have to use pi? circles. And that's what we said, you got oscillation, you got circular motion out there. So they number crunch, in the metric system, 1.56 times t, convert to English, 5 times t is what we get, it was gonna be feet per second. So speed is 5 times t. 5 is fixed, t we said is time, how much? 7 seconds. Now, me and sloppy with units here. 5 times 7 is 35. Since we're in English, feet per second. Well, I don't like that combination of units. We understand feet, we understand seconds. That combination's kind of, well, is that fast or slow? Let's convert. Driving your car, how do you measure speed? Miles per hour. Now these are ugly numbers. So let's go slow. How many feet in a mile? 5,280. Have to divide by that. How many seconds in an hour? Careful. Gotta go to minutes, then you go to hours. How much? 3,600. Gotta multiply by that. Here's what you get. Let's see, 24.5. Yes, that doesn't okay. Miles per hour. Check your notes, fast or slow?
Slow.
We said 30 is normal, so the waves are a little bit slow. We're learning about 24.5 miles per hour. Next up, we want to do wavelength. Wavelength is capital L, according to their symbols. From up top here to this box. If I rearrange this equation for L, what do I get? Rearrange this all for L, what do I get? You're all supposed to know algebra by the time you graduate. So it's going to be C times T. You rearrange the equation, C times T. Let's see. C is speed that we just solved for. Let's go back to the original 35 feet per second. Keep our unit straight. What's T? Time. What's the time factor?
7.
That's twice we've had to use this. So 7 seconds. Seconds top, cancel seconds bottom. I'm left with feet, which I need for distance for wavelength. 35 times 7 is, again, 245 feet. Interesting, we're getting the same digits here. What's normal for wavelength? 300 feet. So the waves are a little closer together. Not spread out quite as much, a little bit closer together. The final factor after frequency. Frequency is F, and we said frequency is the inverse of
How long it takes?
inverse of period. So if you know one, you know the other. It's just the flip. One is waves per time, the other one's time per wave. Alright? How much is the period? 7 seconds. Now that's 3 times we've used this. That is the main factor for figuring out what's going on in the ocean. Yes, we want to know how it feels. We want to know what kind of ride we're going to have if we're out there. But the key is the energy. What the ocean's doing is this one. Because 3 times we've had to use T here. So 1/7 seconds. That means you're going to have 1/7 of a wave every second. Well, that's all right. It's hard to get a handle on that. So let's convert. How many seconds in a minute? So let's multiply by 60 seconds is 1 minute. Multiplied by 1. Seconds top, cancel seconds bottom. How many times does 7 go into 60? 8.5 waves per minute. you notice what's normal? Frequency. That. So a little bit more frequent waves, you're gonna bounce up and down, 8.5 times per minute. The waves are a little closer, speed's a little bit slower. Height 7 feet, 22 mile per hour wind, 80 degrees. What's your conclusion? What's your summary?
It's a nice compliment.
I don't know how common it is, but okay, it's pretty reasonable. Unless you got a really small vessel like a dinghy, you shouldn't have that out there anyway. It's not too bad. It's kind of breezy. As far as the factors for the waves go, it's not that bad. Obviously, a cruise ship, which is huge, will plow right through it. Do not have to do this, but you need to have a feel for the numbers. So if I say sometime, well, the waves out there are only 10 feet apart, you go, what? No, it's way too small. Feel for the numbers. For people that do not like algebra, you've also got another triple axis graph right there. So if you needed to know some of these factors and wanted it real quick, you just check out the graph. Speed, metric, English, wavelength, metric, English, the black line, period. Now notice, all three are increasing. As the period goes up, you're going to the left